Hi everyone listening to me and watching this video. I want to extend my greetings to you. Once again, I'm Erisa back to take you through online math lectures. I'm talking about discrete random variables. That's what we have been discussing, and that's what I'm going to talk about today. We have talked about the mean, and in the most previous lesson, we introduced the variance of a discrete random variable. So today we want to talk more about the variance of a discrete random variable. We say that the variance is abbreviated var of x, where x, the discrete random variable, is given by the expectation of x squared minus the expectation of x squared. So it is expectation of x squared minus the square of the expectation of x. Okay, where e of x is equal to mu, and it is called the mean. We looked at that in the most previous lesson. So we want to look at an example here about this, try to find the variance and then maybe the standard deviation, and thereafter we shall see what comes next. So here with us we have this example that we can talk about and try to solve. The random variable x has the probability distribution as shown in the table. So we have the table showing us the values of x and the probabilities. The first question is to find mu, which is the expectation, find the expectation of x squared, find the variance, and then standard deviation. So the question not really hard, but I'm just trying to ensure that everybody really is free with this and there's no problem anywhere. So trying to clear all doubts so that everyone understands this and can solve problems. Okay, let's do it. From what we have so far discussed, okay, they want us to find the mu, which is the expectation of x. When you look at that question, the expectation is equal to 3. Why 3? The reason is we have these values, 1 with a probability of 0.1, then 2 has a probability of 0.3, okay, 3 has a probability of 0.2, and then 4 has a probability of 0.3, then 5 has a probability of 0.1. So there is symmetry about this value here, okay? The probabilities of the x values as you move away from that average value is the same on either sides, okay? Look at the two corresponding values. 4 corresponds to 2, and 5 corresponds to 1. They have the same probability. The probability of 4 is the same as the probability of 2, and the probability of 5 is the same as the probability of 1. So there is symmetry about x is equal to 3, and therefore that becomes the mean. But it does not stop you from calculating the mean using the formula we have been using. You discover the answer is equal to 3. So part B, okay, we want to talk about the expectation of x squared. This is the summation of all values, probabilities with some x squared times the probability of, okay, for all values of x. And if you substitute in here the x value, we have 1 squared, which is a 1 times 0.1, plus 2 squared times 0.3, plus 3 squared times 0.2, plus 4 squared times 0.3, then plus 5 squared times 0.1. Okay, so what do we get? 0.1, then substitution and get the answer. My mental calculation is 10.4, but you check with the calculator. If it is not correct, then you have to correct it with your calculator. Okay, now C, they want you to find the variance of x. You are required to find the variance of x, which is defined as the expectation of x squared minus the square of the expectation of x. So this is gonna be 10.4 minus 3 squared, okay? And the answer is 1.4. So we are done. D, they want you to find sigma is the standard deviation. Standard deviation is the positive square root of variance of x. So what is the square root of 1.4? That's going to be the standard deviation. Standard deviation. The answer is about 1.18. If you want this to 2 decimal places, it is rounded, it's not so clear. That's why I'm putting 2 decimal places. That's my degree of accuracy. So we have done it. Example 2. Okay, but before this example, there's something I want to give you real quick here about the following results. There's something like we talked about the expectation of any function. There are some results that also hold for variance. Let's see. So the following results relating to variance are useful. Okay, so these results are going to be useful, and we write them down. So we can even prove, but because of time, maybe I'll prove one for you. Okay, so what are the results for A and B? Okay, let me rephrase this so way. If A and B are any constants, okay, then these are the results that we talk about. The variance of a constant is equal to 0. Then 2, the variance of x is a squared times the variance of x. 3, the variance of ax plus ab is equal to a squared variance of x. Okay, so these results are important in discussing this area of discrete random variables. Let me try to prove one for you. Let me prove the first one, which is the easiest. The rest are yours. You're gonna prove in your free time when you're having a cup of chai subi. So let me prove this proof. For the first one, I have variance of a constant is gonna be defined as the expectation of the constant squared minus the square of the expectation of that constant. Okay, so what do we get here? From our discussion yesterday, we said the expectation of a constant is a constant. So even if the constant is squared, okay, even if the constant carries a square, still the expectation, okay, when you square a constant, you get another constant. Okay, so this is gonna be a squared d minus a squared d, which is equal to 0, because this part will produce a, then you square it. Okay, and this part produces a squared. So we have a squared minus a squared, which is equal to 0, and therefore the variance of a constant is 0. So the rest are yours. Reason the same way, you'll get those results. Okay, an example concerning what we have just discussed here. So if you have been given variance, you are required to calculate variance of 2 times the variable. Okay, then you write this as 2 squared d times the variance of x, which is 4 variance of x. If you are given variance of 2x plus 3, this is gonna be 2 squared d variance of x. Okay, the variance of a 3 is 0, therefore this is gonna be 2 squared variance of x, which is still 4 variance of x. Okay, and if you are given variance of 2 minus x, so this is gonna be negative 1 squared d variance of x, and it is simply variance of x. So you should know how to manipulate these results so fast and come up with it, because the testing is gonna be centered about this kind of mathematics. So you take a shortcut, find the answer so fast. Okay, if they want you to prove, but I doubt whether. Anyway, you can always prove to master the mathematics, but I don't think they'll give you question. Anyway, I don't rule it out, but you can always try to prove this. Okay, so next, let's look at this example. So we have the example here. We have been given a PDF, probability of x's for x's. There has been a problem here. So look at this example. The random variable x takes integer values only, and it has a PDF. Okay, they are giving us the PDF. Okay, they want us to find the value of the constant, the expectation, the variance, the expectation of 2x minus 3, and the variance of 2x minus 3. So let's get the value of the constant. To get the value of the constant, sum probabilities, okay? And you know that the sum of probabilities for a random variable equals to 1. So that will solve everything. Let's do it. So we have been given that the probability of x is equal to is kx for x values from 1 up to 5. So this is k, this is 2k, this is 3k, 4k, then 5k. Then from x is equal to 6 up to 9, we have the PDF defined as k in 10 minus x. So 10 minus 4 is okay, this is 6. 10 minus 6 is a 4k. So we have 4k, we have a 3k, then 2k, and a k. Okay, so this is an interesting question. The first part is to find the value of the constant. Okay, let's sum k plus 2k plus 3k plus 4k plus 5k plus 4k plus 3k plus 2k plus a k equals to 1. Okay, so let's sum up and see what do we get when we add all these k's and equate to 1. Okay, so we have 33k, 6k, 10k, 15, 19, 22, 24, 25. So we have 25k equals to 1, meaning that k is 1 out of 25. Okay, so the next part is to get the expectation of x. Expectation of x. When I look at this question, okay, the expectation of x is going to be 5. Why? Because there is symmetry. When you look at this probability, we have 4k, 3k, 2k, and k. 4k, 3k, 2k, and k. So the values, the x values on either side of 5 have the same probability as you move away from 5 on either side. Okay, so the expectation, without wasting time, is equal to 5. But if you want, you can go ahead and calculate it with that value of k. You'll end up with that. Then the expectation, the variance of x is the expectation of x squared minus the square of the expectation of x. Okay, so the task we have here is to find the expectation of x squared. There is no shortcut. This is gonna be 1 squared times k. So 1 times k, okay, plus a 4 times 2k plus a 9 times 3k plus a 16 times 4k plus a 25 times 5k plus a 36 times 4k plus a 49 times 3k plus 64 times 2k, then plus 81k. Okay, that's the expectation of x squared. So what do we get substituting k equals to 1 out of 25? This gives, so the expectation of x squared is 29. What about the variance? Okay, how do we get the variance? The variance of x is defined as the expectation of x squared minus the square of the expectation of x. Okay, and this equals to 29 minus 25, which is equal to 4. So we have the variance as 4. And then the other question is talking about the variance of 2x minus 3 and the variance. Let's do that on next page. They want the variance of, or this about the expectation. It talks about the expectation. So let's talk about the expectation of 2x minus 3. This is going to be twice the expectation of x minus 3. And we know that the expectation of x is a 5 minus 3, giving you 7. So E, what is the variance of 2x minus 3? This is going to be 2 squared times the variance of x. And 2 squared is a 4. The variance is also 4, so the answer is 16. So ladies and gentlemen, we have solved it using just those simple results relating to variance of a random variable. So let me give you this equation. It is for your own consumption. Do it, okay? You can always get back to me. So, question. So, try out this question. It says 2 D6 are drawn without replacement from a box containing 3 red and 4 white D6. If x is the random variable, the number of white D6 drawn, construct a probability distribution table. Okay, so they wanted to find the expectation of x, the expectation of x squared, the variance of x, and the variance of 3x minus 4. It is really a simple question, but the hint I can give you, if you are to construct a probability distribution table, you're going to make use of the tree diagrams to come up with the possibilities. Okay, yeah, that's the hint I can give you. Then from there, you can now construct the probability distribution table. Without constructing the probability distribution table, you cannot answer any of the questions listed down. So it is very, very important as a student, try to gauge your level of understanding. Ladies and gentlemen, I have been a bit disorganized in my discussion today, but it happens once in a while. So this is the end of variance for a discrete random variable. Remember, we are still talking about variance because after discrete random variables, we are going to discuss the binomial distribution as a special discrete random variable, and then we shall also use this in continuous random variables until still coming back up to the normal distribution. So we are not yet done with it, So ladies and gentlemen, thank you for listening to me. I urge you to sell the idea to a friend that there is always a good teacher online. So let them subscribe and click on the notification bell. So ladies and gentlemen, I wish you the best.